So as I have said, today we are looking at inferential data analysis. This is the second level of analysis. The first level is descriptive analysis, which we have completed. We remind you that descriptive data analysis is interested in analyzing data for purposes of explaining a specific sample. But inferential analysis is interested in going beyond the sample by making conclusions or generalizations to the whole population where the sample being described was chosen. In other words, inferential data analysis is interested in using the sample data collected to go beyond that sample and make generalizations to the whole population. Note that inferential data analysis uses data collected from a sample to make conclusions or generalizations on the whole population from which the sample was selected. There are many tools which can allow us to do this, and the procedures we use to make generalizations or to make inferences. And these tools are called inferential data analysis tools, from the word to infer. To infer is to make an inference. An inference, or to infer, is to extend something which was maybe stopping at a particular point, then you extend it to another point where it was not reaching. You help it reach there. Let me hope that maybe it is elastic, or you find ways of making it reach a particular point where it was not reaching naturally. That is to infer, to make an inference. And it is from that inference that we are making conclusions. Conclusions are inferences because conclusions are not derived from the whole population. They are derived from a sample, but they are made about the population. We make conclusions about the population. That's why it is easy for somebody to make a conclusion which is wrong. If you have used the wrong methodologies, you can make wrong conclusions. You are generalizing people when you don't have scientific approaches of making those generalizations. There is a common thing today where people used to think that maybe terrorism is for Muslims. That is a generalization, because you have seen a few cases which are Muslims and then you generalize. The question is, was it a scientific generalization? It is also a common practice by people to generalize. For example, employees always generalize that their bosses are always at war with them. And the bosses always generalize that their employees are always at war with them. Those generalizations are not based on scientific methodologies. Otherwise, here in a statistical, inferential statistical analysis, we are using scientific approaches to make generalizations or conclusions about the population of interest. Let's proceed. Before we look at the inferential statistical analysis tools, it is important we look at some of the key terms commonly used in inferential data analysis. For example, population. When we talk about a population, we mean the totality or the entirety of all the entities the researcher is studying. Let me give an example. If you are studying about households in Kampala, the total population of your study is all the households in Kampala. If you are studying about students in Kampala International University, your population is all the students in Kampala International University. The totality of all students in Kampala International University. Now, the numeric key characteristics of a given population are officially called parameters. Therefore, a parameter is any figure which refers to a population, or any figure which is derived out of the whole population. For example, when we do census, the results we get are parameters because they are from the whole population of the country. So when we talk about parameters, you just know that that is a figure, any figure which is derived out of the whole population. Therefore, when you talk about population parameters, we have said one thing in twice, population and parameter. The examples of parameters, we have the population size. Now you hear population size. This is a number, a figure, abbreviated as capital N in statistics. Whenever we meet capital N, we know that capital N is a parameter and it refers to the population. If you get the population mean, it means the mean you have calculated out of the total population. We always abbreviate it as mu. This symbol is mu. We also have what we call population variance, which is abbreviated as sigma squared. I don't know how do you call this symbol, but me, I call it the sigma squared. We also have what we call population standard deviation, abbreviated as the sigma without a square. There are so many others. Just to know that whenever we calculate any figure, which is from the entire population, that figure is a parameter. It will always have its own symbol. We are not studying about symbols here. So when people look at sigma, they can get scared and worried. No need of getting worried. You can change any symbol and you put there a symbol which is familiar to you. So these are population parameters. These are the parameters we are estimating, because look here, we always have constraints. We always have limited resources in terms of time and money. to collect data from the entire population. For example, if you are studying about students of KIU, you may not be able to reach at every student in KIU because the number is big. You may not have money and time. So you don't have enough space to collect data from the entire population. So we usually select a random sample. I want you to highlight the word random sample. We usually select a random sample from the said population. We collect data from that sample whenever we want to study the population, that population. For example, whenever you want to study anything from students of KIU, you will select a sample. You will use that sample data to understand the nature of students in KIU. And therefore, the statistical tools which you will use to make generalizations are the ones we refer to as the inferential tools. Let's understand another term which is called a statistic. All of you where you are, even though I am not hearing you, don't unmute, keep yourself mute, but pronounce the word statistic to yourself. A statistic is a numerical characteristic of a sample. So whenever you see the word statistic, just know we are talking about a sample. Whenever you see the word parameter, just know we are talking about a population. And we have said that numerical characteristics of a sample are officially called statistics. I also want you to pronounce to yourself the word statistics. So compare it with the first word statistic and then statistics. What is the difference between the two? I want somebody to unmute and you tell me the difference between the two, statistic and statistics. Unmute yourself and you tell me the meaning, the difference between the two. If you fail to unmute, I will select. Let me see who can I select if people. Okay, I see somebody as unmuted. Herbert, tell us.
Yeah, yes, Doctor. Statistic involves numerical characteristics, whereas statistics involves data. That means tables and so many other stuff with it.
Come again?
I'm saying,
yes,
statistic are numerical characteristics of a sample. Then statistics comes after you've I mean the data that you've collected when you're putting it into samples.
Yes, you have tried. You have tried. Statistic. I wanted somebody to look at it in the perspective of the S and without S. Yes, when you have calculated the results, you have put them either on a table or a graph, we refer to them as statistics. Somebody wants to tell us, is called the cipher. Sifa. When I see you unmuted, I believe you want to say something. Okay, let me look at, not yet.
Yeah.
Okay, mute.
Hello, doctor.
Yes, please.
I will also
Sorry, you can unmute yourself. Unmute. Anthony, unmute. Okay, I think we have Anthony did not remember to unmute himself, but let us continue.
Doctor,
Yes.
Doctor, I have something.
Yes, you say it.
Well, I think statistic is that individual or single data that you can, highlight or pick from the general, as statistic is that singular part of.
Yes. Yes, please. We are getting you. Continue.
Of it. Statistics is the entire process. Literally, statistic is a subset of statistics. Thank you, doctor.
Okay, thank you. Thank you, Andela. I tried. I liked the other first part. You said that statistic is that singular part. And indeed it is. When it is one, it is called a statistic. And therefore, when they are many, we call them statistics because they are many. When they are many, they become statistics. Thank you for that. Actually, you may look at the data on the table is called statistics. But when it is one figure, it is called a statistic. You will see how we are going to keep on referring to them, and you'll be able to differentiate further between the two. Otherwise, let us continue. For now, we have indicated that a statistic is a numerical characteristic of a sample, meaning that any figure calculated out of sample data is officially called a statistic. If there are many figures, they are statistics. Examples of statistics include sample size. As you hear, it is a size, it is a number. Therefore, it is a statistic. We usually abbreviate sample size with the small n. We have sample mean, abbreviated as X bar. You see this X with a bar on top of it. You also have sample variance, abbreviated as S, capital S squared, and sample standard deviation, abbreviated as capital S without a square, and many others. Meaning that any figure which you will find, even if it is not among these ones we have mentioned, but it was calculated out of a sample, you know that that is a statistic. Let's proceed. So we said under inferential analysis, we want to understand the parameter. Let me use that language. The researcher wants to understand the parameter, but because he does not have enough resources to collect data from the entire population so that he can compute the parameter, what he does is to collect data from the sample, and then the researcher tries to draw conclusions or to make inferences about that parameter using the corresponding statistic. As you have seen, each parameter has a corresponding statistic which is used to predict it. An inference is also a prediction. For example, when you talk about the population size, we have what we call the sample size. When you talk about the population mean, we have what we call the sample mean. When you talk about the population variance, we also have what we call the sample variance, and so on and so forth. So that is how we come to inferential analysis. At this very point, we would want you to also note that inferential analysis has got Yes, so members, we'll be back from the break. I had ended at a point where we were saying that inferential data analysis has two major branches: estimation of parameters and testing of hypotheses. When we look at estimation of parameters, we have already understood the word parameter. Now we only need to understand the word estimation. We all know from our language what we mean by estimating. So when they say this is an estimation, it means it is not the actual, but you are using some techniques, your understanding, to estimate. So we are estimating parameters, and the reason why we estimate parameters, we have already given. The reason why we study statistics is because we do not have enough resources to collect data from the entire population. If we had all the resources available to understand the entire population, today we would not be here studying statistics, and I would not have a job. Statistics exists because of the scarcity of resources to collect data from the entire population, because we want to make decisions about for the entire population. Unfortunately, we do not have data from the entire population. That's why the science of statistics comes in to help us estimate the parameters. Now, we went by example of a psychologist who wanted to estimate the mean IQ of all pupils in a given school. Because he did not have enough resources to collect data from the entire population, this psychologist took a random sample of 25 pupils. I told you to highlight the word random sample. Took a random sample of 25 pupils and found out that their sample, he calculated the sample mean IQ and found it to be 100. Calculated also the sample standard deviation and got 10. Then we can use these sample results, or we can use these statistics to make inferences about the unknown mean IQ, which is the mu of all pupils in the school. Somebody had not muted. So we are saying that when this psychologist collected data and calculated the descriptive statistics, which is the sample mean and sample standard deviation, how can he make inferences about the unknown mean, the unknown mean IQ of all pupils in the school? At this time, we know that the psychologist or this researcher does not know the mean IQ of all pupils in the school, but the target is to know the mean IQ of all pupils in the school. Because he does not have data for all the pupils in the school, he collected data from a sample and calculated their mean IQ. Remember, this sample must be chosen randomly. If it is not selected randomly, your estimation may not be correct. That's why everywhere you see we are talking about a random sample, a random sample. So when you go to field and you collect data and you don't use random sampling, just know that your results, when you are making predictions, they will not be so good. So we are saying the researcher wants to know the mean IQ of all pupils in the school, which is the mu. But he has data only for a sample. How can he